In this problem, we're going to look at using a trig ratio, a basic trig ratio, to solve for a side. We have a right triangle. They've given us the hypotenuse. They've given us one angle. And the instructions say find CD. In geometry and trigonometry, whenever they use capital letters together like CD, it means the length from C to D. So they're asking for this side right here. Well, they've given you a hint because we know the topic is using trig ratios. So let's identify which trig ratio we might be using. If this is our angle of reference, let's label the side that they're asking for. It's all the way across, so it's the opposite side. The side they gave us, that is the hypotenuse. This side over here, we don't need to worry about. They're not asking for it. Well, if you check your notes, you've got 3 trig functions to choose from: sine, cosine, and tangent. Which of these 3 use hypotenuse and opposite together? Well, you'll find that it's the sine function. So let's write that down over here. The sine of an angle is equal to the opposite over the hypotenuse. This is just the definition, the ratio of that trig function sine. So what you're going to do, now that you know this is the one you're going to use, you're simply going to plug in all the information from the problem into that ratio. So here's what it looks like. The sine of the angle, what angle? The angle of reference, the 22-degree angle, is equal to the opposite side over the hypotenuse. Well, if this is your angle of reference, the opposite is the unknown. So we can put an X there, or a capital CD, since that's what they're asking for. And that's over the hypotenuse. So we go back to the picture and we see the hypotenuse is 8. You see, we've plugged in into the ratio. And so what we have now is an equation with a variable, which means if we do a little algebra, we hopefully can get the variable all by itself to answer the question. All right, let's see what that algebra is going to look like. Change right now because of this trig function. But imagine instead of the sine of 22, there was just a number there. Like, let's imagine it said 100. I'm just making this up. This is not related to that. 100 equals x over 8. It's the same structure as this, but there's just a plain old number there. So what would we do using algebra to get x all by itself? Well, to get 8 to disappear, we would have to multiply by 8 so that you could cancel, and what you do to one side, you must do to the other. And so we would get an answer, x equals 800. Well, we're going to do an algebra step to get x by itself over here. So I'm going to erase this. And I'm going to multiply both sides of the equation by 8 because I want that to be able to cancel out. It is on one. Now on the other side, be really careful to show what I'm doing here. So what's the answer? X is by itself, and it's whatever 8 times the sine of 22 is. Well, that's where your trigonometric calculator comes in. using a TI-30XA, and I turned it on, and I'm going to ask it, what's the sine of 22 degrees? Now, all calculators tend to, have their own steps. You might be using a different calculator. I'm going to try sine. I'm going to put 22, and then I hit the sine button. And it tells me the sine of 22 is this long decimal. Now I'm going to multiply by 8. I'm just going to hit times 8. And it tells me the answer is 2.99 something something, 2.99, and so on. The instructions that we have are to round to the nearest tenth. So I'm just going to round this to 3.0 or just 3. And that is one example of using trigonometry to solve for a side. And by the way, look at the picture. Does it look like this side could be 3? It should look right. So if 8, I could see how this side would be 3. It seems reasonable.